Okay, let's do a simple trig question here. A squirrel on the ground sees a bird on top of a 4.9 meter tree and a chipmunk on the top of a 3.7 meter tree. The angle of elevation to the bird is 52 degrees and the angle of elevation to the chipmunk is 29 degrees. If the angle between the lines of sight from the squirrel to the bird and chipmunk is 103 degrees, find the distance between the bird and the chipmunk. Okay, so let's make a little sketch here of what's going on. So you have your squirrel over here, right? It's not bad. There's your squirrel. You have a tree over here, right? Make a little tree like that, something like that. And then you have another tree over here, like that. Okay, two trees, and on the top of this tree on the left, you're going to have the bird, right? And then on the top of this tree on the right, you're going to have the chipmunk. Chipmunks have a little tail, right? Like that. Okay. Now the angle of elevation from the squirrel to the bird is 52 degrees, meaning that if he's looking up to the bird, like this, he sees here, and now this is a horizontal line. I'm drawing it up like that though because the squirrel is closer to us than the trees are. The trees are off in the distance, right? So this angle here is 52 degrees. And his angle of elevation to the chipmunk, we know, is 29 degrees. Like that. We also know the heights of these trees, right? Like the chipmunk's tree is 3.7 meters. And the bird's tree over here is 4.9 meters. 4.9 meters. The question is, if the angle between these two lines of sight, so this angle here, if that is 103 degrees, what's the distance between the bird and the chipmunk? So we're kind of working in 3D space, right? Because like I said, the squirrel's closer to us than the trees. So these lines that look like they're on diagonals, those are actually horizontal lines, but they're going into the distance, right? Try to imagine that. And then these two imaginary lines of sight have 103 degrees between them. So how can I figure this out? How can I figure out this line here, that distance? Well, first we have to do some work with these triangles, which are right angle triangles, right? If you finish those triangles like that, those are both right angle triangles. Because from those two right angle triangles, if I can find the hypotenuse of each of those triangles, I'll then have two lengths of this big triangle in the middle, right? So that's what we're going to do. First, find the hypotenuse of this triangle on the left, and that triangle on the left just looks like this if you're looking at it from the side, where this angle is 52 degrees and the height is 4.9, and you're asked to find the hypotenuse. You could do that, right? You have the opposite side and you have the angle, so you'll just do sine of 52 degrees is equal to opposite over hypotenuse, right? Solve for the hypotenuse. Your hypotenuse would equal 4.9 divided by sine of 52 degrees, and that would just equal 6.22 meters. So this length here is 6.22 meters. Do the same thing for this triangle over here, right? This triangle, if you looked at it from the side, it would look like this. This is 3.7. This angle here is 29 degrees. Find the hypotenuse. Okay, sine of 29 degrees equals opposite over hypotenuse. Solve for the hypotenuse. Hypotenuse equals 3.7 divided by sine 29 degrees. Therefore, your hypotenuse here is equal to 7.63 meters. So this length here is 7.63 meters. Meaning for this new big triangle, I have a side, an angle, and a side. So yes, of course, this means we are going to be using cosine law, right? Because it's just a big triangle like this, where this is 103 degrees. This length here is 7.63 meters, and this length over here is 6.22 meters. How do I find the side? I'll call that side C. It's c squared equals a squared plus b squared minus 2ab cos c, right? That's cosine law. So c equals square root of all this. So a, I'll make 6.22, plus b, I'll make the 7.63, so that's squared, minus 2 times a times b times cos of angle c, which is 103 degrees, just like that. If you calculate all this, you're going to get 10.87 meters approximately. Round that off if you want to 10.9 meters. So that is the distance separating the bird and the chipmunk. This line here through the air is 10.9 meters. And that's your final answer.